All right, in this video we are going to talk about calculating values of the inverse trigonometric functions. So we'll have to do that pretty similar to how we calculate the values of the trigonometric functions, and there's basically two different ways that we're going to do that. So first is with the unit circle, and then the second is with the calculator. So remember, the unit circle has some special angles labeled on it, and the values of their cosine and sine. And of course, you can get all of the other values of the other trigonometric functions using this unit circle as well. So that is for values that are on the unit circle, that's what we're going to do. And if those, then we have values that we need to calculate that are not one of the special angles on the unit circle, we're going to use a calculator. When you use a calculator, as always in this class, right, you need to make sure that whether you're in the correct mode, degrees or radians. Okay. All right. So let's take a look at how this would go. Okay. And so on the first one, it says find the exact value of the inverse sine of minus square root 3 over 2. All right, so there's some things that you have to remember about this. Number one is you need to remember what the domain of the, or the range rather, of the inverse sine function is. It's from minus pi over 2 to pi over 2. So what that means is that you would be looking on the right half of the unit circle when you do that. And so what you would be doing is you would be looking for a second value where the second coordinate of some point over here has negative square root 3 over 2, right? You can see that's right here. So we're looking from minus pi over 2 to pi over 2. That's the right half of the unit circle. And we're looking for where the second coordinate is negative square root 3 over 2. And then the output would be the angle here. Okay, so the answer would be 5 pi over, or sorry, not 5 pi over 3, because that is not in the correct range. The standard unit circle, right, is labeled from 0 to 2 pi, so it would be minus pi over 3, okay, or minus 60 degrees here. So while using the standard unit circle to calculate these values out that are on the unit circle, you know, it's doable. There's still a lot of things that you need to remember about how this goes. So what I've done is I've created a separate unit circle just for the inverse sine. And basically what I've done is just strip away all of the unnecessary things. Okay. So you can see for the inverse sine, I don't even have the angles over here because it doesn't matter for the inverse sine. The inverse sine is always going to give you an answer from minus pi over 2 to pi over 2, right? Because that's the range of the inverse sine. You see, it's from minus pi over 2 to pi over 2. So that's where the answer is always going to be. Also, I relabeled these, right? The standard unit circle, right, is labeled from 0 to 2 pi. But for the inverse sine purposes, we need the answers to be between minus pi over 2 to pi over 2. So you can see down here, instead of labeling this as 11 pi over 6, I have labeled it as negative pi over 6 or negative 30 degrees, okay? And so on and so forth for these values right here. I've also gotten rid of the first coordinate because you don't need that for the inverse sine. All you need is the values here. So this, to me, really simplifies your thought process about how this works, which is good when you're first learning how to do this. And so I made one of these for inverse sine, one for inverse cosine, and one for inverse tangent. They are all posted in the resources section, so you can, you know, use those to refer to it. All right, it just makes the thought process much simpler. Okay, and so answering our question, I'm going to go ahead and move this over here. So our question that we wanted to answer was what's the inverse sine of negative square root 3 over 2? So we would just pop around the edge, right, of this unit circle that I made for you, looking for minus square root 3 over 2. It's right here. And then we would just look, and the answer would be, the output would be minus pi over 3 or negative 60 degrees. Okay. whether you wanted it in radians or degrees. All right, so that's pretty basic when you're looking for, when you have this simplified version of the unit circle, especially for inverse sine. Okay, so again, the process is you would look up the input, right, around the edge of the circle, and then the output would be the angle. So it kind of reverses the sine function for numbers between minus pi over 2 and pi over 2. Right? Remember, before we were plugging in the measure of the angle and then getting the sine. Here, the sine is the input and the angle is the output. Okay. Okay. So next, let's try that on the calculator. All right. It says find the inverse sine of 4/5 in both radians and degrees. All right. So turn this on. Let's do it in radians and then degrees. So I would need to make sure that I'm in radian mode. And then do inverse sine. So on my calculator, you would hit second and then sine, and you can see the little inverse button in there. So on your calculator, it's probably, really similar functionality to that. So 4/5, that would be 0.927. That's in radians. Okay. So next up, I want to do that in degrees. So go to mode, sorry, and then go to degrees. So now I'm in degree mode. And quit out of there, and then redo this. Inverse sine of 4/5. I get 53.13 degrees, okay, when I do that. All right, let's move on to the next one. All right, so I made a unit circle for cosine. Again, just kind of stripped out anything that wasn't important for the inverse cosine. And here's what it would look like, okay? So for this one, you can see, right, I only have angles from 0 to pi. And the reason for that is because, right, the domain, or the range rather, of inverse cosine is from 0 to pi. So it's always going to give you an answer from 0 to pi, so the upper half of the unit circle. And then we only want the cosines, so that's why I only have the first coordinates here. That's all we're looking for with inverse cosine, right? And that's because the cosine is the first coordinate of those points on the unit circle. All right, and so then I didn't have to do any relabeling. This is how the standard unit circle is labeled. And so now using this, we can easily calculate the inverse cosine values for the special angles. All right, and so let's take a look at how we would do that. And so that's this first example. It says find the exact value of the inverse cosine of negative square root 3 over 2. Right, so I would go to the unit circle and I'm looking around the edge for minus square root 3 over 2. Here it is. I found it, right? And so, oops, that didn't work very well. So it's right here. And so the output would be 5 pi over 6 in radians, or if you want it in degrees, it would be 150 degrees. Okay. Okay, and so then let's take a look at how to do it on the calculator. And this time, let's do the inverse cosine of 17 degrees. All right, so I'm going to clear this out. And let's do radians first. Oops, I keep doing that, but I don't have to. All right, switch to radian mode. And I want to do the inverse cosine, so second and cosine on mine. And then 17 degrees. So, oops. Did not like that. And that's why I did the other thing as well. And the problem, right, with this, I forgot I had put this example here. So The problem with inverse cosine of 17 is that it is not in the domain. So you can see I get this error here on my calculator. And so that's a problem. The domain of the inverse cosine function is from -1 to 1. So 17 is way too big. So if you plug in a number like that and you get that error on your calculator or whatever else, that means that that number is not in the domain. Okay, so I probably should have done that first. Okay, so I get an error like this, and so now you know, oh, you can't take the inverse cosine of 17. Essentially, what it's asking is, what's the angle whose cosine is 17? Well, there's not one, right? Because cosine is always less than or equal to 1, greater than or equal to -1. So you can't have that. Okay, so now let's do inverse cosine of 4/5. So again, I'm in radian mode, so just making sure. And do inverse cosine of 4/5. And I get 0.6435. That's in radians. And now let's switch to degrees and do the same thing. So inverse cosine of 4/5, and that will give us the answer in degrees, 36.86 degrees. Okay. All right. And let's see, Desmos. Let's just double check it on Desmos. On Desmos, if you're using that, you're going to have to type it in as arc cosine. And then it's going to give it in radians. If you want to switch to degrees on Desmos, click the little wrench up here and then click degrees, and it will give it to you in degrees as well. Okay. So you have to type it as arc cos in Desmos. And let's just see what happens when I do. Yeah, you just get undefined there. So you'll either get error or on Desmos it's undefined. So, all right, next one is inverse tan. And here's the unit circle. It's over here again from -pi/2 to pi/2. Okay. Remember, it is undefined at inverse tangent is going to be undefined at -pi/2 or pi/2, right? And here are your around the edge of the circle. Rather, I have labeled it with the tangent, right? So what I did was just do sine over cosine and do that out. Again, just trying to simplify the process as much as possible. Okay. If you do get an undefined value, then it is a little bit tricky. You have to kind of look and see, what you're dealing with. And so I don't think we need to go into that for the Newton homework problems that we'll do in this section. So let's take a look at how this would go. All right, so find the exact value of the inverse tangent of -√3/3. And so I would look around the edge of the circle for -√3/3. It's right here. Okay, and so therefore the answer, the output would be -pi/6 if you wanted it in radians, or -30 degrees if you wanted it in degrees. Okay, so next up is using the calculator. Let's do tan inverse of 4/5. So that would be, let's just again check the mode we're in. Let's do radian mode first. And so you would do inverse tan of 4/5. That's in radians. And while we're in radian mode, we know, let's do tan inverse 17. right? So tan inverse 17 would be 1.51 radians roughly, right? And now you can see, hey, cosine inverse of 17 and sine inverse of 17 were undefined, but tan inverse of 17, right, is defined. And the reason for that is because the domain of tan inverse is from minus infinity to infinity. Any number, you can plug in any number, real number, into tan inverse and get a real number output, a valid real number output. Okay. All right. So now let's do that in degrees and see what we get. So we're going to switch to degree mode. And then do tan inverse of 4/5. So 38.66 degrees roughly. And then if we do tan inverse of 17, we should get something probably pretty close to 90, I think. Yeah. 86.63 degrees roughly. Okay. All right, so that is it for how to calculate these values using both the unit circle and your calculator and Desmos if you're using that as well. Remember on Desmos it's arc sine, arc cos, and arc tan if you're going to do that. Okay, now in the next videos we will take a look at some examples from the Newton assignments and how to work through those.